In this video, we will practice solving rational inequalities. This is AP Precalculus topic 1.8. Again, this is a practice video. If you did not see the previous video where I introduced all of these concepts, you should probably watch that first. This video will make a lot more sense if you do. You can either click the link that appears in the upper right-hand corner or find the link in the description. If you appreciate this content, please don't forget to hit that like button. Before we get into solving rational inequalities, we need to practice finding the zeros of a rational function. That's where the numerator is equal to 0, unless the factor cancels out with something in the denominator. So for problem number 1, we look at the numerator, and we can see that the zeros will be x equals -3 from the first factor, and x equals +2 from the second factor, unless one of these factors cancels out with something in the denominator. Nothing cancels out, so these are the zeros. Looking at problem number 2, nothing is going to cancel out, so the zeros will be where the numerator is equal to 0, and that is simply 0. Be careful on number 3. We will only have one 0. We won't have +3 and +6 because the factor of x minus 6 cancels out. In a later video, we will learn that this is where we have a hole in the function at x equals 6. So the only 0 is at x equals 3. Before we identify the zeros of number 4, we need to factor the numerator and the denominator. So this is going to factor as a binomial times a binomial in the numerator. X squared will factor as x times x. 20 will factor as 4 times 5. Inner plus outer must equal middle. To get a middle of -1, I need a +4 and a -5. Let's factor the denominator in the same way. X squared is x times x. 20 will again factor as 4 times 5. But this time the middle is +1. So I need a -4 and a +5. Nothing cancels out, so I can find the zeros by setting both factors of the numerator equal to 0. So the zeros will be x equals -4 and x equals +5. For number 5, let's again factor the numerator and the denominator. X squared minus 9 is the difference of two squares. This factors as x plus 3 times x minus 3. What about the denominator? This is going to factor as a binomial times a binomial. X squared is x times x. 15 is probably going to factor as 3 times 5. To get a middle of -2, I need a +3 and a -5. So be careful. We will not have two zeros. We will only have one, because the factor of x plus 3 cancels out. So that means we actually have a hole at x equals -3, not a 0. So the only 0 will come from the x minus 3 in the numerator, and that will be x equals 3. The numerator of g of x has a common factor of x. So let's just factor that out quickly before we even begin. So this will be x times x squared minus 4x minus 32. Now let's factor this trinomial from the numerator. X squared will factor as x times x. 32, that can either factor as 4 times 8 or 2 times 16. Let's try these first. It's probably going to factor as 4 times 8. Remember, inner plus outer must equal the middle. If I let the inner term be +4x and the outer term be negative 8x, that will give me a middle of negative 4. So we factored it. Many students have trouble factoring a trinomial like this one, where we have an actual number in the front that's not a 1. So watch this very carefully. 2x squared will be factored as 2x times x. Okay, don't forget about that 2. 4 is either going to factor as 2 times 2 or 1 times 4. So normally I start with the values that are closer together. So normally I would say let's start with 2 times 2. But a hint that I like to use is that if the original trinomial has no common factor, then neither one of the binomials should have a common factor either. So if I put a 2 here, that gives me a common factor of 2. I know that's not going to happen. So that means that 2 times 2 is not going to work out. So it must be the 1 and the 4. It matters which one I put first. Again, I know not to put the 4 here because that still gives me a common factor. There's still a GCF of 4. So I know that it has to be 1 and 4. I don't waste time on any other guesses. The key is inner plus outer must equal the middle. So when I say inner, I'm talking about the 1x. I think I'll put it over here. Inner is 1x. Outer is 2x times 4. That's 8x. Together, I need to make positive 7. So the signs need to be negative 1 and positive 8. So there's my negative 1, and a positive here makes the positive 8 outer. Also, check one last thing. Negative 1 times positive 4 does make negative 4. So we factored it. Before we identify the zeros, look to see if any factor cancels out. And yes, we notice that we have a factor of x plus 4 in the numerator and the denominator. So this will not give us a 0, it will give us a whole, which we will talk about in a future video. So we have 2 zeros, not 3. This x in the front will give us a 0 of x equals 0, and the x minus 8 gives us a 0 of x equals positive 8. The graphs of several rational functions are given below. Use the graphs to solve the following inequalities. Number 7, where is f of x greater than 0? That's going to be above the x-axis. Take note of the x-intercept here at negative 1. Because we only want values where f of x is greater than 0, not equal to 0, I'm going to put an open circle right here that leaves out the endpoint. So above the x-axis is going to be this part of the function, and this entire branch up here is also above the x-axis. Looking at this first interval, f of x is greater than 0 from negative infinity to negative 1. We will use a parenthesis to show that the negative 1 is not included. That goes along with this open circle. Looking at this other branch up here, I'm going to put a union symbol, and this interval goes from 0 to infinity. The 0 is not included. This is a vertical asymptote, and the graph never touches it. So we're going to leave that out. But from 0 to infinity, f of x is above the x-axis, thus greater than 0. Where is g of x less than or equal to 0? Let's start with where it's equal to 0, right here at x equals 1. Because we want values where g of x is equal to 0, I'm going to make this a closed circle. Now the less than part means below the x-axis, so it's going to be this part right here. This is the only part of the function that is less than or equal to 0. This interval, looking at the x values, goes from negative 1 to positive 1. I will put a parenthesis on the negative 1, because this is a vertical asymptote at negative 1. The function g of x never reaches this asymptote, so negative 1 cannot be included. I will put a bracket on the positive 1 for the same reason that I put a closed circle. I want this point to be included because I want values where g of x is less than or equal to 0, and this is where it is equal to 0. Where is h of x greater than or equal to 0? Let's start off with the equal to 0 part. Kabam and kabam. Closed circles because equal to 0 should be included. Now the greater than part means above the x-axis. So that's going to be this interval right here. It's going to be this interval right here. And this entire branch over here, all above the x-axis. So this first interval goes from negative infinity to negative 2. With a bracket, for the same reason I have a closed circle. Union. This middle interval goes from negative 1 to 0. The negative 1 gets a parenthesis because this is a vertical asymptote and the function never actually touches it. The 0 gets a bracket for the same reason I put a closed circle there, or equal to 0. This is included. Union. And this last branch right here goes from 1 to infinity with a parenthesis on the 1 because it's a vertical asymptote and the function never actually touches it. So that's number 9. Okay, now let's solve some rational inequalities. I'm going to refer to this left part of the inequality as f of x. The first step is to find and list off the zeros of f of x. So I like to label it like this. Where does f of x equal 0? A function will equal 0 only where the numerator is equal to 0. So that's at x equals negative 2. We also need to find another critical value, which is where f of x is undefined. A rational function will be undefined where the denominator is equal to 0. So that's at x equals 1. Now we make a sign chart. When you make a sign chart, you make a row for every factor. So we have the numerator and the denominator. That'll be 2 rows. This first vertical line is just for labels. Other than this, I need a vertical line for every critical value. I'm going to put both of these critical values across the top in order from least to greatest. This is a number line. Label your sign chart. I'm just going to call this f of x. This first row will be for the factor in the numerator, and the bottom row is for the x minus 1. From least to greatest, the negative 2 goes first, and the positive 1 goes second. Now we need to decide if these factors are positive or negative in each interval. The x plus 2 factor gave us a 0 of negative 2, so this is the only place where x plus 2 might change signs. In this case, x plus 2 is negative to the left of negative 2 and positive to the right. If that's not obvious to you, just pick some values to test. For example, a number to the left of negative 2 would be negative 3. If I plug in negative 3, that would be negative 3 plus 2, that's negative 1. That tells me that we're negative over here. A value to the right of negative 2 would be 0, for example. If I plug in 0, I get positive 2. So, negative on the left, positive on the right. Similarly, the factor of x minus 1 gives us a 0 of positive 1. This factor is negative on the left and positive on the right. The overall sign of f of x will depend on how many minuses you see. An even number of minuses gives you a positive value. An odd number of negatives is negative. And of course, all positives is definitely positive. We are looking for the values of x that will cause f of x to be less than 0. So we want the interval where f of x is negative. Should we include the endpoints? Well, no. We are only looking for the values of x that cause f of x to be less than 0, not equal to 0, negative 2, and definitely not where it's undefined. So we will show that the endpoints are not to be included by using parentheses. So I'll write the actual solution down here, negative 2 to 1. So this is the solution in interval notation. I'm not going to do this every time, but I am going to write this as an inequality just to show you that you can. So you could write this as negative 2 is less than x, which is less than 1, for example. Okay, number 11. Where does f of x equal 0? That's where the numerator equals 0. That's x equals 3. Where is f of x undefined? That's where the denominator is equal to 0. X equals negative 5. Set up your sign chart like this with a row for each factor. Be sure to put your critical values in order from least to greatest. X minus 3 gave us a 0 of 3. This factor will be negative on the left and positive on the right. X plus 5 gave us the 0 of negative 5. It will be negative on the left and positive on the right. The overall sign of f of x will be positive in the first interval because of the even number of negatives. It will be negative in the middle interval because of an odd number of negatives, and positive in the last interval. We are looking for values of x that will cause f of x to be greater than 0. So the solutions will be in the intervals where f of x is positive. That's here and here. We will not be including any endpoints this time because we only want values that will cause f of x to be greater than 0, not equal to 0, not undefined. We will show that we are leaving these out by using parentheses in the solutions. So this first interval is from negative infinity to negative 5, and then union 3 to infinity. Here's how you would write that same solution as an inequality. Look at number 12. Where does f of x equal 0? Well, that's going to be where the numerator is equal to 0, but because there's a constant there, that means there are no values of x that will cause this fraction to equal 0. But there are other critical values we must consider. Where is f of x undefined? That's where the denominator is equal to 0, which happens at x equals 1. Set up your sign chart like this, with your two factors and your one critical value. The negative 3 is negative in every interval. The x minus 1 will be negative to the left of 1 and positive to the right. F of x will be positive in this first interval because a negative times a negative is a positive, and it will be negative in the second interval. We are looking for the values of x that will cause f of x to be greater than or equal to 0. So we will find solutions in the interval where f of x is positive. However, well, I started to say we will also include any values that will cause f of x to equal 0 because we want or equal to 0. But this number 1 is not such a place because f of x is actually undefined here. So you will never include an undefined value in the solution. We will show that 1 is not included by using a parenthesis. So this interval goes from negative infinity to 1. So this is the solution in interval notation. Number 13. Where does f of x equal 0? This will be where the numerator is equal to 0, which is simply at x equals 0. Where is f of x undefined? That's where the denominator is equal to 0, which happens at x equals 4. On the sign chart, we will have a row for the x and a row for the x minus 4 squared. Make sure you include that exponent. It is important. Put your critical values in order from least to greatest, 0 and 4. X is obviously negative to the left of 0 and positive to the right. X minus 4 squared is positive in every interval because when you square even a negative number, it becomes positive. F of x will be negative in this first interval because of the odd number of negatives, and it will be positive in the remaining intervals. We are looking for the values of x that will cause f of x to be less than 0. In other words, negative. Not equal to 0, so we will not include the 0 itself. We will show that 0 is not included by using a parenthesis. So this one interval goes from negative infinity to 0. So that's it. Easy peasy. Where does f of x equal 0? That's wherever the numerator is 0. So x equals 1 and x equals negative 6. Where is f of x undefined? That's where the denominator is equal to 0. So x equals negative 2. Setting up the sign chart, we have a row for every factor. X minus 1, x plus 6, x plus 2. We put the critical values in order from least to greatest. So negative 6, negative 2, and positive 1. X minus 1 gave us the 0 of 1. It will be negative to the left and positive to the right. X plus 6 gave us the 0 of negative 6. It will be negative to the left and positive to the right. X plus 2 gave us the 0 of negative 2. Negative to the left, positive to the right. F of x will be negative in the first interval because of the odd number of negatives, positive in the next interval because of the even number of negatives, and similarly it will be negative here and positive here. We are looking for the values of x that will cause f of x to be less than or equal to 0. So the solutions will be in the intervals where f of x is negative. We will include any endpoints where f of x is equal to 0, because we want the values of x that will cause this to be less than or equal to 0. So I will put a bracket on the 1 and the negative 6 when I write the solutions. I'm going to put it now so I don't forget. So I'll need a bracket on the negative 6. I will need a bracket on the 1 when I do this interval. However, the negative 2 will get a parenthesis when I do this interval, because that's where f of x is undefined, and we don't want that. We want less than or equal to 0. We don't want undefined. So we will show that we are leaving this value out with a parenthesis. So the first interval goes from negative infinity to negative 6 with the aforementioned bracket. And then union negative 2 to 1, and there's another bracket for you. That's it. Number 15, where is f of x equal to 0? That's where the numerator is equal to 0. So that's going to be at x equals 3 over 2 and x equals negative 4. Where is f of x undefined? That's where the denominator is equal to 0, which is at x equals 0. Set up your sign chart like this, with a row for every factor, including this x squared, and with your critical values in order from least to greatest across the top. This is a number line. So 2x minus 3 gave us the 0 of 3 over 2. So this is the only place where this factor might change signs. Normally I just say it's going to be negative on the left, positive on the right, because that's usually what happens. And maybe it will happen again, but this does have this extra 2 here, so let's take a moment and think about it. So let's see, to the left of 3 over 2, this is 1.5. So 0 is to the left. If I plug in 0, then that's just going to leave negative 3. So yeah, it is going to be negative on the left. I said this is 1.5. I could have used 1 would be on the left. If I plug in a 1, that would be 2 times 1, which is 2, minus 3, which is negative. Will it be positive on the right? To the right of 1.5 would be 2. If I plug in a 2, that's 2 times 2, that's 4, minus 3 is positive 1. So, as it often is, we get negative on the left, positive on the right. Anyway, x plus 4 gave us the negative 4. This factor is negative on the left, positive on the right. X squared gave us the 0, but that doesn't matter. Because it is squared, this factor will be positive in every interval. F of x will be positive in this first interval because of the even number of negatives, and it will be negative in the next interval, negative in the next interval, and positive in the last interval. We are looking for the values that will cause f of x to be greater than or equal to 0. So the solutions will be in these intervals where f of x is positive. Because we want greater than or equal to 0, we should include any endpoints where f of x is equal to 0. So I will show this by putting a bracket on the 4 and a bracket on the 3 over 2. So the solutions are from negative infinity to negative 4, bracket, union, bracket, 3 over 2 to infinity. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.